Hello students, today we are going to learn about how to solve rational inequalities or fractional inequalities. This topic is very important for both classes 11 and class 12. So let us start. Solving a rational inequality. A rational expression have both numerators and denominators. Thus, we have the following possible combinations. So what are the possible combinations? Either both the numerator and denominator are positive and the overall result will be positive, right? For example, 6 upon 2 will be equal to 3. If the numerator is negative and denominator is positive, the overall result is negative, like minus 6 upon 2 is minus 3. And if both numerator and denominator are negative, again the result is going to be positive. And if numerator is positive, denominator is negative, in this case also the result is going to be negative. Now to solve the rational inequalities, we use a similar procedure for solving the polynomial inequalities, with one exception. We must eliminate values for x that makes the denominator equal to 0. Once expressions are combined into a single fraction, the value that make either the numerator or denominator equal to 0, that divide the number line into intervals, and we can find the solutions. Let us take one example. Solve x minus 5 upon x plus 2, that is less than 0. So clearly you can see this is the case of a rational inequality or fractional inequality. Now we know that for this fraction x minus 5 upon x plus 2, this will exist if the denominator x plus 2 is not equal to 0. That is, x is not equal to minus 2. Okay, so my denominator should not be equal to 0. So what can happen? If it is not equal to 0, then either it can be less than 0 or it can be greater than 0. So two cases arise here. The first case is when x plus 2 is greater than 0 or x is greater than minus 2. Okay. And the second case we need to discuss here is that when this x plus 2 is less than 0 or x is less than minus 2. So let us study individually what is going to happen. Now, we need to understand that in case of a fraction, we are having one numerator and one denominator, and I need the overall result to be negative as per the required problem. So overall result will be negative. If numerator is positive, then denominator should be negative, and in that case, overall result is negative. And if numerator is negative, denominator should be positive. In that case also the result is negative, right? If both of them are of same sign, like both are plus or both are minus, the overall result is going to be positive. Now as you can see, my x plus 2 is greater than 0, which is the denominator. So for my fraction to have the less than 0, right, means it should be negative, then it will be negative if my numerator is having the opposite sign. So if it is positive, then it should be negative. That means what do I get? X is less than 5. Okay. So combining these two results, and we should get something common. Okay. So from 1 and 2, what do we get? X is greater than minus 2 and x is less than 5. So can I write like this? Minus 2 is less than x and x is less than 5. And both combined together can be written as that x is lying between minus 2 and 5. Okay. And can be written as, because the sign is of strict inequality, x belongs to open interval minus 2, 5, which can be represented on number line like this is, say here lies minus 2, here lies 5. Okay. So as the case is of open interval, so you can put a hole here, which indicates that the endpoints are not included, right? And this is the solution portion. This is the solution portion except from the endpoints. So these holes, they clearly indicate that the endpoints are boundaries are not included. Okay. So this case gives you this solution. Let us see the other side, other case, which kind of solution it is framing. Now again, as you can see, my x plus 2, that is denominator, is negative. Now in that case, my x minus 5 upon x plus 2 will be less than 0 if x minus 5 is positive, right? That means x is greater than 5, right? So let us now interpret. Are we getting something common, some common portion, that x is less than minus 2 and x is greater than 5. Let us see and plot it, the case on number line, infinity, minus infinity. This is minus 2 and 5 here. So x greater than 5 means the case is towards this side. Okay. And x less than minus 2 means the case is towards this side. So we are not getting any common solution. Okay. So in that case, we say that there is no solution. So overall, this case can be rejected, right? So what is the required solution of this problem? The required solution is this one. That is, x belongs to open interval minus 2 and 5. So let us take one more example. Solve the inequality 1 upon mod x minus 3 less than equal to 1 by 2. So clearly it is the case of our fractional inequality or rational inequality. So clearly what should happen? The denominator should not be equal to 0. That means mod x is not equal to 3. Right. Moreover, 1 upon a is less than equal to 1 upon b. Right. This is something like 1 upon a is less than equal to 1 upon b. So cross multiply, b is less than equal to a. So can I write it as a greater than equal to b? Yes, because both means same thing. So if this is 1 upon a less than equal to 1 upon b, so I can write it as my b is less than equal to a, or a is greater than equal to b. So we get mod of x is greater than equal to 2 plus 3 implies mod of x is greater than equal to 5. Now we know that mod of x means it is x if it is positive and it comes out as minus x if it is negative. So I can write it as plus minus x greater than equal to 5. So two conditions we get from here, x greater than equal to 5 or minus x greater than equal to 5. So that is x greater than equal to 5, or we need to multiply this by minus 1 to make x positive. And we know whenever we multiply by minus 1, the direction of inequality changes, right? So it becomes x less than equal to minus 5. So we get x greater than equal to 5 and x less than equal to minus 5. Now how it can be represented on number line? This is your number line. This is say 5 and this is minus 5. So as it is the case of our inequality involving our equal to sign, that slack inequality. So less than equal to minus 5 towards this side and greater than equal to 5 towards this side, right? So that means whole means this holes are covered means minus 5 and 5 are also included. So we can write it as x belongs to, see, from minus infinity to minus 5. So as the sign is of your equal to, so semi closed and double will be used. Union greater than equal to 5 means from 5 to infinity. But still the solution is not complete. Why? Because one additional condition was also there, that mod of x minus 3 is not equal to 0. So if it is not equal to 0, means that either my mod of x minus 3, this is greater than 0 or it is less than 0. Okay. So if it is greater than 0, then what happens? And if it is less than 0, then what happens? Okay. So let us discuss these cases that we will discuss separately. So either mod of x minus 3 is greater than 0 or mod of x minus 3 is less than 0. So it becomes mod of x greater than 3. That means plus minus x is greater than 3, implies my x is greater than 3 and minus x is greater than 3. Now let us make it positive by multiplying with minus 1. So we get x is greater than 3 and x, inequality changes its direction, x becomes positive and 3 is negative, right? So x is greater than 3 and x is less than minus 3. So how to plot this solution? This is infinity, this is minus infinity, minus 3 and 3 here. So less than minus 3 towards this side and greater than 3 towards this side. Okay. Now, as the case is of strict inequality, so we need to put a hole here to indicate that the endpoints are not included. So let us see the other case. So here mod of x is less than 3 implies plus minus x is less than 3 implies x is less than 3 minus x less than 3 implies x is less than 3 and x is greater than minus 3. Again, what happened? We multiplied this by minus 1 to make x positive. So this can also be written as that minus 3 is less than x. So both results can be combined together. Minus 3 is less than x and x less than 3. So we can write it as that x lies between minus 3 and 3. That is, x belongs to open interval minus 3, 3. So solution can be represented as, this is say minus 3, this is 3. As the case is of open interval, so this is the desired solution. Endpoints are not included. Okay, from minus 3 to 3 and the endpoints are not included. Right, but earlier also one solution was there. We need to combine those results now. And that solution was that x belongs to our minus infinity to minus 5 semi-closed interval and then union from our 5 to infinity. Okay, and where from minus 5 to 5 the result was not included. Now definitely this case is between from minus 3 to 3. We can discuss that. If I summarize both the results, see now what is going to happen. Observe the number line. This is infinity, this is minus infinity. Previously it was minus 5 and here it was 5. Now we are having minus 3 and here it is 3, say 0 is here. So less than minus 5 we did earlier and now less than minus 3 means towards this side. Again greater than 5 was towards this side, so greater than 3 was towards this side. Now you know, for both these cases the summary is like this: whatever is less than minus 5 is automatically less than minus 3 also, right? So writing x less than minus 5 is sufficient. Towards this side, x is greater than 3 or x is greater than 5. So I think whatever is greater than 5 is greater than 3 also. So we can write that x is greater than 5, right? So both results can be summarized that here combined common portion is that x is less than minus 5 and x is greater than 5. Okay, and as the condition is that we have to include minus 5, so the semi-closed interval will be there. So means less than equal to minus 5, that result will be there. So the common portion is your x less than equal to minus 5 and here it is x greater than equal to 5. Okay, so we need not include this portion, right? Now this is the portion which we need to include now, because the solution also includes this, because endpoints are not included, right? And this says belongs to open interval minus 3 and 3. So the solution also includes this portion from minus 3 to 3 and your endpoints are not included, right? So how can we write the solution combinedly now? That x belongs to, combining these two results 1 and 2, x belongs to our minus infinity to minus 5 union. Now you get from open interval minus 3 to 3 union, again semi-closed interval from 5 to infinity, right? So this is the desired solution, right? So because we need to consider just the common solution, so we need to eradicate our, because that will not be included. So this portion we don't need to take. So solution of that is covered from this side. So from less than minus 5 we will see the common portions now, and this is your towards this side, and the solution open interval from minus 3 to 3, which is the required solution.